Hello everyone. So we are here with another very interesting problem of mathematics. Again, this is very common problem and one very important application of Pascal's triangle that we are going to discuss here. Again, this is very general topic, so it's useful for all the mathematics lovers. Okay. So now let's start. Even if you are not in mathematics, you can definitely watch this. So you'll find one very interesting. You will learn something new here. So the problem here is following right moves or up moves, in how many ways a person can reach from A to B. A simple diagram I have, right? I want to go from A to B. In how many ways I can reach from A to B following only right move or up move, okay? So it's very easy. You can easily answer this question that if I have to go from A to B, I have to go from A to B. There are only two ways, following only right moves and up moves. So this is one way and this is another way, right? This is another way. So this is one way, that is if I say this is 1 and this is 2, I have A, then 1, then B. This is one way, and second is A, 2 and B. Now you must be thinking, what is so exciting about this? Now let's talk about this. In how many ways I can reach from A to B, again following the right move and up move. So again, you can easily count, no big deal. You can easily count. Let's say this is 1, 2. I'm just naming these points. So in how many ways you can reach here? You can see 1, that is A, 1, 2, B. This is one way to reach, right? Or we can have A, 3, 2, B. That is this, right? 1, then. Or what is the third way? You can see this is the third way, you can see, which is A, 3, 4, B. So there are how many ways? In how many ways you can reach from A to B following the right move and up move? This is only 3 ways. In this case, we have two ways, not one way. Here we have 3 ways. Okay. No big deal. Now let's move to the next part. In this case, again, you can easily count. You can say this is one way, this is second way, and this is the third way. There are 3 ways from A to B. Okay. Now, if I ask you about this, how many ways in which you can reach from this point A to this point B, then it is very difficult because you might miss some ways because there are so many paths we have. So how to mathematically derive from number of ways from A to B using only up move or right move, right? So that is what we are going to discuss if we have any path here, right? So now, what is Pascal's triangle? This was given by Blaise Pascal, very famous mathematician. What is a Pascal's triangle? If I write, let's say this is 1, then if I again write 1, 1, now you see the pattern. On this line, on this side of the triangle, I'm just writing this 1. Right? On this side of the triangle, I am writing 1. Now see, 1 plus 1, this will give you 2. Correct? Now, 1 plus 2 is giving you 3. 2 plus 1 is giving you 3. I'm just going down, right? Then 1 plus 3 will give you 4. 3 plus 3 is giving you 6. 1 plus 3 is giving you 4. This is, now if I follow the same pattern, 1 plus 4 is 5. Then you can see 6 plus 4, this is 10. Then 6 plus 4 again, this is 10. 4 plus 1, this is 5. So you can see if I just draw this, I can just continue this. I can continue with the same way till the last point. So you can see I have got 1. This is one triangle we are getting. This is why this is called Pascal's triangle. There is nothing related to triangle. The only thing is this is something forming a triangle. That is why this is called Pascal's triangle, right? So you can again continue. After that, what will be the row? 5 plus 1, 6, 5 plus 10, 15, 10 plus 10, 20, 10 plus 5, 15, 5 plus 1, that is 6. If you know the concepts of binomial expansion, then this can be very easily related to binomial NCR, NPR. So we are not going into details of those things. What we are trying to do is we are using this concept, Pascal's triangle, to solve the problem which I have just given to you. Okay. So now, how this can be used here? Rohan wants to reach from home to school as fast as possible. Rohan is standing here and his school is, let's say, here. This is the problem. Rohan wants to reach from this place, home, to school as fast as possible. Please help him find the number of paths through which he can reach. Now, if you see, I want to reach as fast as possible. These are the paths which I followed, right? So the only possibility, if you want to reach faster, you have to just move right and up so that you are very close to S, that is school, right? So indirectly the question is, you have to move only right and up. Then that will be the fastest way, right? Now, how many such paths are possible so that you can reach from this place, his home, to this place? Now, see. If Rohan wants to go from this to this, there is only one path. This to this, there is only one path. So I'm writing this is one. Here also it has one path. Here also it has one path. Like Rohan can go from here to here only one way. Rohan can go from here to here only in one way. You can see only you are moving only right or left or up. Similarly here, only one way. Same logic, Rohan can reach from here to here in one way. Similarly here in one way, here in one way. Now, in how many ways this person Rohan can reach to this? I want to reach to S, right? So you can see I can reach in two ways, which is 1 plus 1. This is 1 plus 1. Now, in how many ways this person can reach here? This is 3 ways. The condition is he is moving only right and up. Okay, shortest possible, right? Similarly, in how many ways he can reach from here to here? 4 ways. You can count, you can write the diagram, you can mark the path, and you will see that if Rohan wants to reach here, he will have only 4 ways moving up and right. Okay. Now, in how many ways Rohan can reach here? It will be 3 ways. 2 plus 1. That is 3 ways. In how many ways Rohan can reach here? Here, this is 6 ways. This is 3 plus 3. In how many ways Rohan can reach from here to here? This is 10 ways. 6 plus 4, this is 10. You can see Pascal triangle. 6 plus 4, 10. 3 plus 3, 6. 1 plus 2, 3. Now, in how many ways Rohan can reach here? 3 plus 1, that is 4. In how many ways Rohan can reach here? This is 4 plus 6, that is 10. And in how many ways Rohan can reach from here to here? This is 20 ways. 10 plus 10, that is 20. So in how many ways Rohan can reach from his home to school? That is total number of ways is 20. This is the application of Pascal. So this is the application of Pascal's law. So this is the shortest possible path. All the paths will have the same length. The only thing is the total number of paths will be 20. Okay. So this is the answer. And if someone knows the concepts of permutation and combination, I can say the total number of ways in which the person can reach from this place to this place will be, we have 3 horizontal and 3 vertical, which is 6 factorial divided by 3 factorial, 3 factorial. Total number of ways, because in any case, he has to move 3 horizontal step and 3 vertical step. So that will be 6 or 3 horizontal, H, and 3 vertical, that is 1, 1. So what is the arrangement of this? You can say this is 6 factorial divided by 3 factorial, 3 factorial. If you just check this, 6, 5, 4 divided by 6, which is equal to 20. So this is the mathematical way to solve this by using permutation combination, but this is a general method which can be applied by any person, any common man, right? Now let's apply to this the same concept to the next question. Following only right moves and up moves, how many ways a postman can reach from post office to home? Again, same thing. Post office here, the person wants to reach to home. He wants to deliver something to this home, right? So in how many ways you can do this? Now, you can pause this video and you can try this. You can just start 1, 1, 1, 1. What is 1, 1? These are number of ways from here. Let's say the person is starting here. From here to here, only one way at any point, right? Same here, 1, 1, 1, 1. Now, total number of ways to reach to this, 3, 4, 5. Now you can easily write this, 2 plus 1, this is 3, 3 plus 3, this is 6, 6 plus 4, this is 10, 10 plus 5, that is 15. Similarly, this is 4, this is 10, this is 20, this is 35. You can see this is 15 plus 20, 35. So total number of ways to reach here, 35. Same. Now again, 5, 15, 35, right? Am I correct? Yes. So total number of ways here will be equal to 70. Now, if you know the concepts of permutation combination, you see how many horizontal steps, in any case, how many horizontal steps he has to move, 1, 2, 3, 4. And how many vertical steps, 1, 2, 3, 4. So this is 8 factorial divided by 4 factorial, 4 factorial. Basically, 4 horizontal and 4 vertical steps the person has to. If you just check this, this is 8 into 9 into, 8 into 7 into 6 into 5 divided by 4, 3, 2, 1. So you can see this is cancelled and this is also cancelled. So this is 70. Total number of ways from this place to this place via shortest possible path or following the right move or up move, 70 ways. Okay. Now let's move to the next part, next question. Now this is some constraint. We have some constraint here. Read the question. Mr. Roy is traveling by his car from for a meeting to town B. This is Mr. Roy. He is somewhere here. I think this diagram is hidden. So let me see if I can do. Yes. So this is the diagram. Okay. So the person is this. Mr. Roy is standing here. He has to go from here to here. If he has to travel via shortest path, same logic, shortest path, that is either he will move right or up. Same logic, because again, he has to be closer to P, right? And has to meet a friend in the town A. He has to meet his friend in town A, the total number of ways in which he can do it. So the constraint here is person, this Mr. Roy has to meet his friend at A. Then he has to go to B. Okay. So total number of ways in which he can do this via shortest path will be what? So this is the answer. This is the question. Now, logic is same. The only thing is, first he has to reach to point A. Then from A he has to reach to point B. Right? So now let's start. First we have to reach to A. So this is 1, 0. The person is starting from here. This is 1, 1, 1 and 1. Okay, same thing. I think we don't have to go to this side, because if the person is reaching A, okay, he cannot go to this point because this is more than this and he cannot come down definitely, right? So I am just focusing on this. So I'll just take this part. This is 1, 1 and 1. Now see, this is 2, this is 3, correct? 2 plus 1, that is 3. Now this is 3. This is 6. This is 3 plus 1, that is 4. Now this is 6 plus 1, that is 10. So there are 10 ways to reach to A. After reaching A, obviously the person cannot come down because he has to move from the shortest path. Correct? So now see, if I have to go now from A to B, in how many ways I can reach to this place? In how many ways I can reach to this place? That is only 10 ways. Because the person will directly move to this. So if the person can reach here to the 10 ways, he has to reach by the same way to this place, that is 10 ways. And in how many ways the person can reach here, that is 10 ways. I hope this point is clear. This is the tricky part, right? Because this is the only way he has to move. This is the only way he has to move from here to here. So path will not change here, right? So total number of ways in which he can reach to this point, that will be 20. In how many ways the person can reach here? You can see this is again 10. Why? Because this cannot possible that he is going up and then coming down. He has to go up only. So the total number of ways for this path is also same, 10. So total number of ways from here to here, this will be equal to 30. So I hope this is clear. All right. Or otherwise, if you know the permutation combination, so in how many ways the person can reach to A? First, person has to reach to A. So in how many ways? We have 2 horizontal steps and 3 vertical steps. This is 1, 2, 3 vertical and 2 horizontal. So that is 3 horizontal and 2 vertical, right? Sorry, 2 horizontal and 3 vertical. He has to move in any case 2 horizontal and 3 vertical. So in how many ways person can reach here to here? This is 5 factorial divided by 2 factorial, 3 factorial. Now after moving from A to after reaching to A, in how many ways person can reach from A to B? He has to move 2 horizontal and only 1 vertical. So this is into 2 horizontal and 1 vertical. So that is 3 factorial divided by 2 factorial, 1 factorial. This is PNC concept. I'm not going into details of this. So this is 10 into 3, which is equal to, you can see I have got the same answer by this, by this. This is the general method which can be applied by anyone who does not even know the mathematics, right? For this, you have to know the concepts of permutation combination. Now I am leaving one question for you. An ant is on its way to collect food. There is some insect, some ant, right? For its army, but must be carefully avoid spider. That means if this is going, it is going from here to here, right? This is the food, right? It has to be careful and it has to avoid this spider. How many ways are there such that this and Z to do so? That means effectively the question is this insect has to go from here to here, but he cannot come at this place because there is a spider sitting. In how many ways this can be done by this? Okay, so I'm leaving up this question for you. You can try this question. You can answer this in the comment section. Then if you want me to make the video for this question also, I'll definitely make the video for this, but do comment in the do write your answer in the comment section. So I hope you have liked this concept. You have enjoyed how to calculate the number of ways, shortest path from some point A to some point B. You can try these type of questions. This is one more question which you can try. Same thing, how many shortest routes are there to go from A to B while passing through point C? While passing through point C. Assume only downward movements are allowed. Now, again, this question I'm leaving for you. These 2 questions, you can write your answers in the comment section. I'll definitely make this video if there is some interest in this. Okay, so that's it for now. I hope you have enjoyed this. Thank you.